Welcome back. So the example is here. There are two variables. Variable is one, the information is given about the percentage of players on ground and age and their age. So the for one particular age, say for 10 years is the age, then among all the 10 years kids, what is the percentage of kids those who play on ground? I mean the physical activity. So this is the two given data. Age is given along with its percentage of players on ground. So these two things are given. Okay, so using scatter diagram, we have to find a correlation between them. Okay, so we need to check whether as age compared to considering the age, how it will go on increasing, decreasing. Is there any kind of correlation of low degree, high degree, or perfect, or exactly there is no correlation? So this is what we need to check. Okay, now we have to totally consider into the data given, but considering the facts around us that the kind of age where usually student or the people play on ground is in between 15 to almost 25, then again over the period of time that went on decreasing, and as you age more, then less students or less what do you say, less number of people actually play on ground. So you may expect that if age increases, then the percentage of players may decrease. So negative correlation we may expect as per the real facts, but we have to take into consideration only this data which is given. Considering these all values, only we have to find out whether is there any correlation, and if it is there, it is which kind of correlation. So now if you look at the values of age given 25, then 40, then 45, then 15. Okay, then we have 30 here. So it is not given in the order. So if the values are given in order, I mean if one side is ordered, and in that case it will be easy for you to understand whether it's a positive correlation or a negative correlation just by looking at the table. But in this case there is no any sequence. So in that case one thing is that, well, obviously we have to take help of scatter diagram. Another thing to understand quickly what you can do. Okay, for 25 it is 71, then 40. So there is increase in the age 25 to 40. Then what happens to this 71 to 50? It is a decrease. Then 40 to 45, again it's increase. Then 50 to 40, it's still decrease. Then there is 15, 45 to 15, it's a decrease here, but here it is 40 to 75, it's increase. So if you consider the first four cases, increase, decrease, I mean it's opposite direction. One increases, another decreases. If one decreases, another increases. So you may really have the negative correlation, but I have studied only four cases. It's just my assumption. I'm just trying to guess. So we have still remaining other entries. Okay, so this way also you can have idea about whether it is going to give you positive or negative correlation. Alright, now we will draw scatter diagram for it. So any one you can take on x-axis, another on y-axis. So usually we go for the first row on x-axis and the second row on y-axis. Two axis. So y-axis is my percentage of players. And x-axis would be age of players. Okay, now we have to finalize the scale for it. Okay, so now to make a scale, first you need to understand the range of this variable. What is the minimum and maximum value? So in the age we have 15 is the minimum age here and 60 is the maximum age. So we have from 15 to 60, these all values we have to cover on x-axis. Okay, so now when you have to show, manage with the values of x and y axis, instead of starting from 0, okay, you can, after 0 you can immediately start with the least value in the entire list. So suppose on my x-axis, actually I want to have the values 15 to 60. So I may start directly from 15 here. I will skip the values between 0 and 15 because there are no any values. So though I will have origin from 0 here, so I am interested only from the part 15 to 60. Okay, so that way I will adjust my scale. Now here you have to be very careful. The scale of x and y, you have to consider the unit change in x and y, and accordingly you have to take the scale. Otherwise what happens, you may have this diagram which is where you have points very much near to each other, but it is not actually high degree correlation, or you zoom out, or I mean you expand it so much that though it is high degree correlation, the points are at the very much distance and you may assume it as the low degree correlation. So all it depends on the x and y axis. Those x scale has to be correlated those has to be balanced with each other. So for age, there is a constant age change of 5 everywhere, and for percentage of players, there is a change of or random values like from 71 to 50. So it is almost 21 is the gap, and 25 to 40 is 25. It is still similar. Then 50-40 is 10 gap here, and here it is 5. So here it is 75, 6, 68. So this is the kind of gap. Okay. So now considering that, so for y-axis, I have to show the minimum value is starting from 6 and maximum value is 75. Okay. So then on x-axis, for 1 unit I take 5, and for y-axis for 1 unit I take 10. Okay. Let me mark the values here for y-axis. Okay, my graph x and y axis are ready. Age, I'm starting from 15. Okay. So I'm just trying to draw straight lines. All right. So now for every pair we have to plot a dot of x and y, x versus y, x and y axis. Now if you consider the first pair, age is 25. So my value of x is 25 and y is 71. So for 20 value for 20. So it is then for 38 it is 68. 68 is again much near to 70. Then we have next entry 20, 70. So for age 20, 70%. This is again near to 70. Then for age 35, it is 65. So for age 35, it is 65. Then for age 50, it is 30. So 30% comes somewhere here. And for age 55, it is 10. Alright, all the dots are plotted on the graph sheet. I mean on the blackboard. We have plotted all the dots, and if you hear the dots here, all of them are starting, I mean it is a clear cut correlation, and the correlation is negative correlation. Now what do you tell about their degree, whether it's a low degree correlation or high degree correlation? In that case, if you remember the previous scatter diagrams, if you have a straight line and all the points are falling in the one straight line, then it is a perfect correlation. So it can be positive or negative. Now in this case, these 1, 2, 3, 4, 5, these points would make come on the one line, but you have to leave these two as well as these three. So in this way, if you go, then this will be, I mean, it is not possible to have all of them on one particular line. So it is much clear it's a negative correlation, but it's not perfect negative correlation, whether it's a high degree or low degree. Now if you consider the scatter of them in maximum 2 lines or 3 lines, you can have all of them lying in one particular disk. Okay, so there is no scatter in between them. Okay, so this is, you can consider the high degree negative correlation. So from scatter diagram, you have to give the remarks on it. So from scatter diagram is age increases, the percentage of player for that age group decreases. Okay, so this is what the negative correlation is, and it's a high degree negative correlation as considering these values. Okay, now in the case, suppose here if you expand this y-axis more, okay, you make it more tall, the y-axis, then what happens, the difference between these points will also increase. Okay, so in that case, if you have the very large scale, in that case, you may not assume, or you may not, what do you say that this is a high degree correlation. So it also largely depends on the axis what you take, or the scale for x and y axis. So it depends on the cluster of values, how do you present them. So if you drag it in both the directions, then obviously it is going to scatter. And if you take too small scale, then obviously it is going to become very small, and you may, you may assume it as the high degree correlation. So actually this is one kind of drawback of scatter diagram, that it will tell you definitely about negative or positive correlation, but to understand it is high degree or low degree, what you need to understand is the distance between them, the unit distance between them, and how the unit distance is making difference in another variable. So scatter diagram may not give you the clear cut picture about whether it is low degree or high degree correlation based on this way. So if your scale what you have taken is perfect, then it will still tell you about whether it is low degree or high degree correlation.